So let's now look at some problems on properties of triangle. First problem, the altitudes of a triangle are in the arithmetic progression. Then the sides of a triangle are in first option AP, second option HP, third option geometric progression, fourth option arithmetico-geometric progression. Now, let's consider a triangle ABC. We are given that the altitudes are in arithmetic progression, AD, BE and CF. Let us say they are the altitudes. AD, BE and CF are altitudes and are in arithmetic progression. They are in arithmetic progression. We know that half BC into AD is equal to delta. So in other words, AD will be equal to 2 delta by BC. What is BC? Generally the notation for the side opposite to the vertex A is denoted by small a. The side opposite to the vertex B is denoted by small b. The side opposite to the vertex C is denoted by small c. So what is AD? AD will be equal to 2 delta by A. Similarly, BE will be equal to 2 into delta is the area of the triangle ABC. Delta is the area of the triangle ABC. So 2 delta by B will give us BE, and similarly CF is 2 delta by C. So clearly 2 delta by A comma 2 delta by B comma 2 delta by C are in AP. This is given arithmetic progression. When some numbers are in AP, if you divide each number by a common number, we still get an AP. So what we have here is 1 by A, let's divide throughout by 2 delta. So 1 by A, 1 by B, 1 by C are in AP. So from here we can infer that ABC are in arithmetic harmonic progression. ABC are in harmonic progression, HP. So the sides are in harmonic progression, and clearly option 2 is the right answer. So option 2 is the right answer. One thing that we need to bear in mind is the altitudes are given by 2 times the area of the triangle divided by the side onto which the altitude is drawn. So 2 delta by A, 2 delta by B, 2 delta by C. These are the altitudes, and we have the option 2 here. Let's move on to the next question. Question number 2. If twice the square of the radius of a circle is equal to half the sum of the squares of the sides of the inscribed triangle ABC, then sin square A plus sin square B plus sin square C is equal to first option 1, second option 2, third option 4, fourth option 8. We have a circle and there is an inscribed. So we have a circle and let's say ABC is an inscribed triangle in it. Let us say the circumradius is capital R. Now by sine rule, A is equal to 2R sin A, B is equal to 2R sin B, and C is equal to 2R sin C. What is A? The side opposite to the angle A, and B here, small c here. This we know by sine rule. Okay, right. Now we are asked to find out what else is given. Capital R square, the square of the radius is equal to half of the squares of the sum of the squares of the sides of the inscribed triangle. Half of a square plus b square plus c square. This is what is given to us in the problem. So what is that? Okay, therefore we have 2r square is equal to a square plus b square plus c square. But what is our a square plus b square plus c square? 4r square into sine square a plus sine square b plus sine square c. Okay, here this r square and thus this r square can be cancelled. You have, so what do we have here? What do we have here? 1 by 2 is equal to sigma sine square a. Using the sine rule, we have a to be 2r sine a, b to be 2r sine b, c to be 2r sine c. What's given in the problem is 2 into r square is equal to half times of a square plus b square plus c square. That gives us 4r square to be equal to a square plus b square plus c square. That is 4r square sine square a plus sine square b plus sine square c. Is equal to 4r square. This 4r square can be cancelled and we have sigma sine square a to be equal to 1. And that's what that is appearing clearly in the option 1. Option 1 is the right answer. Now, let's move to the next question, question number 3. If the line joining the circumcenter O and the incenter I is parallel to BC, then cos B plus cos C is equal to, first option 3 by 2, second option 1, third option 3 by 4 and fourth option 2. So let's have a look. We have a triangle ABC. Let us say incenter is here and circumcenter is O. It says IO is parallel to BC. If you drop a perpendicular from I on to BC, what is this length? Let's say the foot is some L. What is the length IL? That's nothing but the in radius. I am dropping a perpendicular from I onto the side BC, or to any side the length will be small r. That length will be small r. What is that small r? The in radius. In radius. Okay. Now when you drop a perpendicular from circumcenter on to any side, it has to bisect that side. So when you drop a perpendicular from O, the circumcenter, on to any side, it will bisect the side. So D will have to be the midpoint. Let's drop a perpendicular from O on to BC. D will have to be the midpoint. So D is the midpoint, BD is equal to DC. Alright. Now clearly, because IO is parallel to BC, the small r should be equal to OD. So OD is equal to small r. Okay. Now, but what is OD? Capital R cos A. This angle subtended by any side at the circumcenter will be twice the angle it subtends on the circumference. Now this angle is A, this angle here to be should be 2A. This ODC triangle is congruent to OBD triangle, therefore you have this angle to be A here. This is also A. Now this is capital R. Now what is OD? OD is capital R cos A. Projection. Capital R cos A will be OD. So what is small r by capital R for us from here? Cos A. We know one result. We know that cos A plus cos B plus cos C is equal to 1 plus 4 sin A by 2 sin B by 2 sin C by 2. From transformations of transformations. Okay. Now this small r and capital R related like this. Small r is equal to 4r sin A by 2 sin B by 2 sin C by 2. We have a relation like this. So small r by capital R will be 4 sin A by 2 sin B by 2 sin C by 2. So in other words, what you have here is, this is true for any triangle and this is also true. So small r by capital R is equal to 4 sin A by 2 sin B by 2 sin C by 2. So this 4 sin A by 2 sin B by 2 sin C by 2 can be replaced by 1 small r by capital R. Therefore, cos A plus cos B plus cos C in any triangle, this is, we know that in any triangle, in a triangle ABC, not just this triangle, for this triangle our small r by capital R is equal to cos A. So we will use that is 1 plus small r by capital R for any triangle. But from the given conditions, small r by capital R is equal to cos A. So I will write this to be, therefore what should have happened? This cos A and small r by capital R are one and the same. Therefore cos B, so therefore cos B plus cos C must have been equal to 1, is equal to 1 there. So in this, given that IO is parallel to BC, we could conclude, we could use the fact that small r, which is the perpendicular distance from I on to BC, I to BC, will be same as the distance from, perpendicular distance from circumcenter to the side BC. What is that distance? Capital R cos A. So R is equal to capital R cos A. Small r by capital R will be therefore equal to cos A. Now, but we also know a fact that cos A plus cos B plus cos C is equal to 1 plus small r by capital R for any triangle. Therefore, cos B plus cos C has to be, because since these two are equal in our problem, in the given problem, so cos B plus cos C has to be 1 in that problem, and that is clearly appearing in the option 2. So option 2 is the right answer. Let's move to the next question, question number 4. If O is the orthocenter of the triangle ABC, then the distance from O to the side BC is, first option 2r cos B cos C, second option 2r cos C cos A, third option 2r cos A cos B, fourth option r cos B cos C. Let's have a look here. We have a triangle ABC. Let us say H is, orthocenter is O here. Let S be the circumcenter. Let G be the centroid. We know that S, G, O have to be collinear. This is called the Euler line. And OG is to GS is equal to 2:1. What is O? Orthocenter. G centroid. And S the circumcenter. Orthocenter. Centroid, circumcenter, circumcenter. All these 3 points, circumcenter, all these 3 points are collinear. All these 3 points are collinear, and the ratio in which G divides OS is 2:1. OG is to GS is 2:1. This is a fact to be remembered. Okay. In fact, that can also be proved actually. You drop a perpendicular from S on to BC, that's going to bisect it. So D is the midpoint of BC. So BD is equal to DC. When you join S and D, you're going to have it to be perpendicular. Okay. Now let us join AD. That AD line will definitely have to be containing the centroid, and centroid also lies on this line OS. So obviously the point of intersection of these two lines, that is AD and OS, has to be G. This angle and this angle are both equal, vertically opposite. Okay, and we see that we'll call this as some AL. AL is actually parallel to, what is AL? Parallel to SD. Therefore, this angle and this angle also will be equal. So the triangle, if you look at AOL, AOG triangle, the triangle AOG, two of the angles of the triangle AOG are same as the some corresponding angles of the triangle SGD, SGD triangle. Okay, and they are similar triangles. So what is it you can say? AO by SD, AO by SD, these are the sides corresponding to these two angles which are equal. AO by SD should be equal to AG by GD. And what do you know? We know that the centroid divides the median in the ratio 2:1. This is 2:1. So that is 2:1. So what is AO? Your AO has to be equal to 2 times SD. What is SD but? Let's join S and C. That will be capital R. SC will be capital R. So that is, this angle is A, angle A. So R cos A will be SD. So 2 into R cos A. So AO length will be 2R cos A. That is, a distance between vertex to its orthocenter will be equal to 2R times the angle from which, the vertex from which, cos of the angle from which, corresponding to the vertex from which that altitude has been dropped. So AO is 2R cos A. Similarly, BO will be 2R cos B, because now it's coming from B, 2R cos B. CO will be 2R cos C. CO will be 2R cos C. Okay. Now, all right, here, so CO, this is CO, we are interested in the distance, let us say OL. What is OL distance? The distance from orthocenter to the side BC. That's going to be, let's consider the triangle BOL. We know that if you extend this, this is going to be a right angle triangle. It's going to be a right angle triangle. This is C, therefore this will be 90 minus C, and therefore this will be C, angle C. That is, I extend B to meet, to pass through O and meet AC in some point M. Now in the triangle BMC, the angle C is there, and therefore this will be angle MBC will be 90 minus C. Therefore angle BOL will be C, because this is 90. Okay, now we know that this BO length is 2r cos B. Now the projection of that 2r cos B into cos C will be the side OL. So 2r, that is going to be, that's going to be OL will be equal to the projection of BO, it is BO cos C. But what is BO? 2r cos B into cos C. Therefore this will be 2r into cos B cos C. So OL is 2r cos B cos C, and AO is 2r cos A. These two can be remembered, but here I am just proving it. Okay, so AO is 2r cos A and OL is equal to 2r cos B cos C. So cosines of the arms of this angles opposite to this, alright. So 2r cos B into cos C. Therefore the answer is option 1 is the right answer. Option 1 is the right answer. In a triangle ABC, sigma A cube cos of B minus C is equal to, first option ABC, second option 2ABC, third option 3ABC, and fourth option 0. What we will do is, we will verify for an equilateral triangle. What is it you get? A equal to B equal to C, let us say. Verify. And A capital B equal to capital C equal to capital A. Angles also will be equal. Each is equal to 60. So what do you get in that case? We will get A cube into cos of B minus C will be 1. Again A cube plus A cube. So that makes it 3A cube. Can we write that as 3 into ABC? Because B and C are both equal to A. So clearly option 3 is the right answer. Option 3 is the right answer. So this is by, I am doing it by verification for equilateral triangle. Equilateral triangle. Okay. So problems related to the properties of triangles we could verify for equilateral triangle, the identities. So we have here, I am verifying for equilateral triangle here. Of course it can be proved using the sine rule. A is equal to 2r sin A, B is equal to 2r sin B, and C is equal to 2r sin C, and done. Okay. So anyway, that comes out to be 3ABC. So here we will save time by verifying for equilateral triangle. So option 3 is the right answer. Let's move to the next question. Question number 6. A triangle ABC is such that A cos A is equal to B cos B. Then the triangle is right angle triangle. Second, isosceles. Third, right angle or isosceles. Fourth option, equilateral triangle. Here A cos A is equal to B cos B. That's what is given to us. We know that A is equal to 2r sin A and B is equal to 2r sin B. 2r sin B. This is by sine rule. So we will apply, we will use those values here, formulae. So we have 2r sin A cos A is equal to 2r sin B cos B. 2r cancels and we have here sin 2a to be equal to, let's only cancel r. So 2 sin A cos A is equal to 2 sin B cos B, and that gives us sin 2a equal to sin 2b. So sin 2a is equal to sin 2b. A and b are angles in a triangle. What could have happened? 2a is equal to 2b, or 2a is equal to 180 minus 2b. These are the two possibilities. So 2a is equal, because they are angles in a triangle. So a is equal to b is what you can get, which means that this would imply that the triangle is isosceles. The triangle is isosceles. Two of the angles are equal, the triangle will be isosceles. Or 2a plus 2b is equal to 180. So that gives us a plus b to be 90, which also gives us angle C to be 90, because angle A plus angle B plus angle C in a triangle is 180. So we have one of the angles to be 90. So definitely the triangle would have been, in this case it would have been an right angle triangle, right angled at C. So either the triangle will be isosceles or it will be right angled. Therefore the option 3 is the right answer. Option 3 is the right answer. That's the right answer. If in a triangle ABC, a square plus b square plus c square is equal to 8r square, then the triangle is, first option right angle triangle, second option isosceles, third option equilateral, fourth option scalene. ABC and capital R are in the standard notations here. Okay, so let's see here. A square plus b square plus c square is equal to 8r square. Using the sine rule, we will have 4r square into sigma sine square A will be equal to 8r square. So this r square cancels and we will have a 2 here. So sine square A plus sine square B plus sine square C is equal to 2. Is equal to 2. We will take a 2 multiplied here. So 2 into sigma sine square A is 2 into 2, 4. That is 4. But what is 2 sine square A? 1 minus cos 2a. So 1 minus cos 2a plus 1 minus cos 2b plus 1 minus cos 2c is equal to 4. So what is it you can say from here? 3 minus cos 2a plus cos 2b plus sigma cos 2a is equal to 4. So sigma cos 2a will have been equal to minus 1. Would have been equal to minus 1 here. Okay, so but what is sigma cos 2a? Let's use the transformation here. Cos 2a plus cos 2b plus cos 2c. Okay, is equal to minus 1 here. Now what is cos 2a plus cos 2b plus cos 2c? We have okay, so cos 2a plus cos 2b plus cos 2c plus 1 is equal to 0. We have that. Now let's have a look. What is cos 2a plus cos 2b? 2 cos of a plus b into cos of a minus b. What is 1 plus cos 2c? 2 cos square c equal to 0. You know that cos of a plus b is equal to a plus b is equal to 180 minus c. Therefore, cos of a plus b will be equal to minus cos c. So we have therefore cos c common here. 2 cos c into cos c minus cos of a minus b is equal to 0. So therefore what is it you have here? What is it you can say? This is 2 cos c, and what is this? This is minus of cos of a plus b into cos of minus of cos of a minus b. equal to 0. So this minus and minus, I'll take out a minus common and we'll have plus there. That makes it minus of 2 cos C into 2 cos A cos B is equal to 0. That gives me cos A is 0 or cos B is 0 or cos C is 0. So therefore, either A or B or C will be 90. This implies angle A is 90 or B is 90 or C is 90. So one of the angles will definitely have to be, a right angle there in the triangle, using the condition A square plus B square plus C square is equal to 8R square. We have arrived at this, and we use the transformation. We just pull that minus 1 this side. So 1 plus cos 2C is 2 cos square C, we know. So now we are getting cos C common, and then we have this. So what are we having here? One of them has to be definitely a right angle. Therefore, the triangle is right angled. The option 1 is the right answer. Option 1 is the right answer. Let's move to the next question. If two of the angles of a triangle ABC are 45 degrees and 60 degrees, then the ratio of the smallest and the greatest sides are root 3 minus 1 is to 1, second option root 3 is to root 2, third option 1 is to root 3, fourth option root 3 is to 1. The angles are, two of the angles are 45 and 60. So obviously the third angle should be 180 minus of 45 plus 60, that's clearly 75. So the angles of the triangle are 45, maybe 45 here, and 60 here, and 75. Obviously, the side opposite to the smallest angle will be smallest, and the side opposite to the biggest angle will be biggest here. So this would have been, let's call this as ABC. Angle B is the largest here, therefore AC will be largest. This is the largest side. And of course, this being the smallest angle, this will be the smallest side. The side opposite to the smallest angle will be the smallest, and side opposite to the largest will be the largest. Largest angle will be largest side. Okay, so this is how we have here. Now what we want is the ratio of the largest is to ratio of the smallest. So what is that? AC by AB is what we want. We want AC by AB. Okay. We know that AC by sin 75 is equal to AB by sin 45. That's by sine rule. Okay, so AC by AB will be sin 75 divided by sin 45. So using this, we are getting this sin 45. And what is that? That's clearly sin 75 by sin 45 will be root 3 minus 1. Okay. So sin 75 by sin 45 will be root 3 minus 1. So that's clearly root 3 minus 1 is to 1, and hence option 1 is the right answer. Okay, let's move to the next question. In a triangle ABC, if B by C plus A plus C by A plus B is equal to 1, then angle A is 60, first option. Second option, angle B is 60, angle C is 60, third option, angle A is 90, that's the fourth option. So let's have a look at this. We are given B by C plus A plus C by A plus B is equal to 1. This is what is given. So let's take LCM. What do we have? B into A plus B plus C into A plus C is equal to A plus B into A plus C. Let's take it the other side. Is equal to A plus B into A plus C. So what do we have here? AB plus B square plus AC plus C square. We have A square plus A plus AC plus BC A square plus AC plus BA plus BC. This AB cancels and this AC and AC cancels here. So what do we have here? B square plus C square minus A square is equal to BC. So this is close to the cosine rule formula. What is the cosine rule? What does the cosine rule say? Cos A is equal to B square plus C square minus A square by 2BC. So what we have here, therefore B square plus C square minus A square, we will write this as we are given B square plus C square minus A square is equal to BC, will write it as 2BC into half. So bring down that BC here, 2BC top. So what do we have? Therefore B square plus C square minus A square by 2BC is equal to half. What have I done here? This is the formula. So I was trying to match it up with the formula, this part. B square plus C square minus A square is equal to BC. So the right hand side we will multiply and divide by 2. So 2BC into half. Now the 2BC I will pull it down so that this will match with cos A formula. This is cos A. So cos A is equal to half, that is cos 60 clearly. So A has to be 60. So therefore option 1 is the right answer. Let's move on to the next question, question number 10. In a triangle ABC, 2AC into sine of A minus B plus C by 2 is equal to, first option A square plus B square minus C square, second option C square plus A square minus B square, third option B square minus C square minus A square, fourth option C square minus A square minus B square. Now, so 2 into AC into sine of A minus B plus C by 2. That's what you wanted here. Let's have a look. This we will write it in the form of A plus C minus B by 2. We can write it as A plus C is 180 minus B. So that makes it 90 minus B. Because this will be 180 minus B. This is my B again, 180 minus 2B by 2, that gives us 90 minus B. So what you have is, what you wanted is 2AC into sine of 90 minus B. This is what is asked for. So what is that? 2AC, this is 2AC cos B. But what is cos B? Let's use the cosine rule formula. So that is 2AC into A square plus C square minus B square by 2AC. So this 2AC cancels here and we have here A square plus C square minus B square. So clearly that is appearing in the option 2. So option 2 is the right answer. So we are using the cosine rule here, cosine rule formula. What is that? Cos B is equal to A square plus C square minus B square by 2AC. So 2AC cos B will be A square plus C square minus B square there. So option 2 is the right answer. Option 2 is the right answer. Let's move on to the next question, question number 11. Two straight roads intersect at an angle 60 degrees. A bus on one road is 2 kilometers away from the intersection and a car on the other road is 3 kilometers away from the intersection. Then the direct distance between the two vehicles is. First option 1 kilometers, second option root 2 kilometers, third option 4 kilometers, fourth option root 7 kilometers. So there are two straight roads which are converging at a point O, let us say AO and BO. Now here is a bus and here is a car here, let's say car. C for car, B for bus. Let's have. So we have and B here. He says bus is on the road which is at a distance of 2 kilometers and car is on the other road which is at a distance of 3 kilometers from the intersection point. This angle is given to be 60 degrees. Now what he is asking is BC. This is what is asked. So clearly cosine rule can be applied. Use cosine rule. Since we know this angle and we know the arms of that angle, so we can find the side opposite to that angle. So cosine rule, what is that? Now cos of 60 will be equal to 2 square plus 3 square minus this, well let's call it as some x square divided by 2 into this arms of the angle 2 into 3. So cos 60 is 1 by 2. So 2 square plus 3 square, that is 4 plus 9, 13. 13 minus x square is equal to 2 into 2 into 3. So 1, 2 will cancel and we have here 13 minus x square to be equal to 6. So clearly x square is equal to 7, x will be root 7. So this side will be root 7. This side is root 7. So clearly the direct distance between the bus and the car, B for the bus and C for car I have said. O is the point of intersection of these two roads. So the angle in subtended angle is 60, we know, given, right? So use the cosine rule to find out this value. So that is root 7. So option 4 is the right answer. Option 4 is the right answer. Let's move on to the next question, question number 12. In a triangle ABC, cos C plus cos A divided by C plus A plus cos B by small b is equal to 1 upon A, first option, second option 1 by B, third option 1 by C, fourth option C plus A by B. In a triangle ABC, the side opposite to the angle A is small a, B and small c here. Now, okay, A is equal to B cos C plus C cos B. The side A will be equal to B cos C plus C cos B. That can be easily proved here. Drop an altitude from A. Let us say the foot is D. A is nothing but BD plus DC. BD plus DC. BD plus DC. A is BD plus DC. But what is AD? BD? That is C cos of B. That is, this is BD. And B cos C will be DC. This is B. This is DC. So BD plus DC is your, this is what is the projection rule. Projection rule. This projection rule will be used here. Okay. Now what is given? So what we have is A is equal to B cos C plus C cos B. B will also be equal to, what about B? B will be equal to C cos A plus A cos C. And C will be equal to A cos B plus B cos A. So continuation of this projection rule. Okay. Let's see here. Cos C plus cos A by C plus A plus cos B by B is what we require, and all the options are in terms of the sides. So we'll have to convert this into the form of sides. So B into C plus A, let us take the LCM. B cos C plus B cos A, and what do you have here? C cos B plus A cos B. I am just cross multiplying here. This is what it is equal to. But what is B cos C plus C cos B? That is A. B cos C plus C cos B is equal to A. So these two add up to A. What about B cos A plus A cos B? That adds up to B cos A plus A cos B adds up to C. So A plus C. Numerator we have A plus C. In the denominator we have B into A plus C. So this A plus C and A plus C cancels, and we have therefore 1 upon B. So we repeatedly used a projection rule and we got this. What is the answer? Answer is clearly option 2 is the right answer. Let's move to the next question, question number 13. In triangle ABC, if sin A plus sin B plus sin C multiplied with sin A plus sin B minus sin C is equal to 3 sin A sin B, then the angle C is equal to what? First option 30 degrees, second option 45 degrees, third option 60 degrees, and fourth option 120 degrees. Now let's have a look here. Sin A, can I write it as in the form of A by 2R? Sin B will be B by 2R. Sin C, C by 2R. Let's write like that. We therefore have sin A plus sin B plus sin C. We'll then have A by 2R plus B by 2R plus C by 2R multiplied with A by 2R plus B by 2R minus C by 2R is 3 times of A by 2R into B by 2R. So what do we have here? We have here, in fact, this 2R and this 2R can be cancelled out. It's 2R. So what do we have? A plus B plus C into A plus B minus C is equal to 3AB. So that clearly gives us, we'll treat this as one term here, A plus B whole square minus C square is equal to 3AB. So that gives me A plus B whole square minus 3AB is equal to C square. But what is A plus B whole square minus 3AB? This is A square plus B square minus AB is equal to C square. Because you get a 2AB here, 2AB minus 3AB is equal to this. So clearly from here A square plus B square minus C square is equal to AB. This AB will write it in the form of 2AB into half. So half will be equal to A square plus B square minus C square by 2AB. And that's very clearly, this is cos of C. This is cos C is equal to half. This gives us angle C is equal to 60 degrees. So bear this in mind, whenever you get a condition like this, A square plus B square minus C square is equal to AB, it clearly implies that angle C has to be equal to 60. So C is 60 and the option 3 is the right answer. So option 3 is the right answer. In a triangle ABC, cot A by 2 plus cot B by 2 plus cot C by 2 is equal to A plus B plus C square by 4 delta. Second option, A square plus B square plus C square by 4 delta. Third option, A plus B plus C the whole square by 4 delta. Fourth option, A plus B plus C whole square by 2 delta. Now we have a formula, cot A by 2 is equal to S into S minus A by delta. cot b by 2 will be obviously s into s minus b by delta. Cot c by 2 is equal to s into s minus c by delta. Cot c by 2. So when you add them up, what do we have? So sigma cot a by 2 is s by delta. We find s by delta common in everything. S by delta into s minus a plus s minus b into s plus s minus c plus s minus c. So that gives me s by delta into 3s minus a plus b plus c. But what is a plus b plus c? What is s here? Semi-perimeter. That is a plus b plus c by 2. So a plus b plus c we can write it in the form of 2s. So 3s minus 2s by into s by delta. What is that? That's going to be s square by delta. So sigma cot a by 2 is turning out to be s square by delta. What is s? Semi-perimeter. And what do we have here? Let's get back to, because the options are in terms of ABC, let's get back to the options. So that comes out to be a plus b plus c by 2 the whole square by delta. And that's clearly a plus b plus c whole square by 4 delta. 4 delta. And that's appearing in the option 3. Option 3 is the right answer. Question number 15. The perimeter of a triangle is 16 centimeters. One of the sides is of length 6 centimeters. If the area of the triangle is 12 square centimeters, then the triangle is, first option, right angle triangle. Second option, isosceles. Third option, equilateral. Fourth option, scalene. The perimeter of the triangle is 16. So a plus b plus c is 16. Okay, so s will be 8. Yes, the semi-perimeter will be half of this perimeter, so that is 8. One of the sides is of length 6, so let us say a is 6. This implies b plus c has to be 10. B plus c has to be 10. And what else we are given? We are given that area of the triangle is delta is equal to 12 square centimeters. 12 square centimeters. Area of the triangle is 12 square centimeters. Okay. But what is area of given in terms of the sides? We use the Heron's formula. Delta is equal to root over s into s minus a into s minus b into s minus c. Here s is 8, so 8 into 8 minus 6 into 8 minus a into 8 minus b into 8 minus c under root. That is 8 into 2, 16. Pull it out to the square root, we have 4 into under root over 8 minus b into 8 minus c. That's our delta, which is equal to 12 square units. 12 will cancel out 4 factor. So we'll have 3. 3 is equal to under root over 8 minus b into 8 minus c. So from here 8 minus b into 8 minus c has to be 9. 3 square. We're squaring both sides. Squaring both sides, here we have 8 minus b into 8 minus c to be 9. Now let's have a look here. B plus c is 10. So let's then look at what is 8 minus b plus 8 minus c. That is 16 minus of b plus c, that will be equal to 16 when consider 8 minus b plus 8 minus c. That is 16 minus of b plus c, and that is equal to 16 minus 10, that is 6. So we have here sum of two numbers, 8 minus b and 8 minus c. Let us think them there x and y. X plus y is 6 and x into y is 9. Clearly 8 minus b has to be 3 and 8 minus c also has to be 3. So sum is 9, sum is 6 and product is 9. You can easily prove that these two are both equal to 3. So this implies B has to be 5 and C also has to be 5. So both of them are equal. B and C are equal here. So it's clearly an isosceles triangle. So 6, 5, 5 are the sides of the triangle. These are the sides. So of which two of the sides are very clearly equal. So hence the triangle is isosceles. So we can't say it's equilateral because all the sides are not equal. We don't even have it to be right angled, and it's not scalene because all the sides are, it's not that all the sides are unequal. Two of the sides are equal, therefore it's clearly an isosceles triangle. So option 2 is the right answer. Option 2 is the right answer.